Hi everyone, welcome to this video. In this video we're going to have a look at linear approximation, and the first thing to note is for small values of x, the sign of x is going to be that value of x, roughly. So it only works for small values of x, and similarly for cos, it's 1 take 0.5 x squared. I'm not going to go through where we come up with those in this video. So just note that we've got two definitions. Sine of x is roughly equal to x, and for cos, it's roughly equal to 1 take half x squared. And that's only for small values of x. So first question says using the linear approximations for sine of x, we want to evaluate sine of 3 degrees. And comparing the accuracy to the calculator, just depending on what we get. So sine of 3 degrees. 3 degrees, I'm going to convert that to radians. So if I do that, 3 degrees is going to be pi on 60. And so what I can say for sine of x, it's roughly equal to x for small values of x. So therefore, because pi on 60 is such a small value, okay, 60th of a pi, we can say sine of pi on 60 is roughly equal to pi on 60. So therefore, I can say sine of 3 degrees, it's roughly pi on 60. On a calculator, if we work out what sine of 3 degrees is, we get about 0.05234. And if we type in what pi on 60 is, we get 0.05236. So extremely close. It's only in this last value where they differ. So the two values would be essentially the same, expressed to 3 decimal places. Part B, so show that the root of the equation cos x equals 1, sorry, undo that. So cos x, take 12x squared equals 0 for x values between 0 and 0.4. So let's say f of x is equal to cos of x, take 12x squared. I'm going to find out what f of 0 is by subbing in x equals 0. If I work that out, I get cos of 1, cos 0, which equals 1, take 0, so it's just 1. And that's obviously greater than 0. I'm next going to find out what f of 0.4 is. So cos 0.4, take 12 times 0.4 squared, roughly minus 0.9989. Okay, obviously a little bit less than 0. Therefore, there is a root for which lies between 0 and 0.4. Because we've got one which is at 0, it's greater than 0, one which is less than 0, so it has to be between those 2 points. And the last question, use the quadratic approximation 1 take 0.5 x squared for cos of x to obtain an estimate of the roots in part B. So we know that it's between 0 and 0.4, and because they're small values of x, we can say cos of x is roughly 1 take 0.5 x squared. So if we let them equal each other, we'll have a very close approximation. So the equation cos of x take 1 plus 0.5 x squared equals 0. Solving for 0, sorry, we don't want that one. We want this one here. So cos of x take 12x squared. So when that equals 0, we know cos of x is 1 take 0.5x squared, so let's replace that. And then solving for x. We find that x squared is about 2 over 25. So as an estimate, plus or minus 0.2828. So the root for which x is positive is 0.2828 to 4 decimal places. So that's example 16. So that's all we need for 9.6. So have a go at the questions. Thanks for watching.